Welcome to Math with Mrs. Bibb. In this video, we will review how to factor quadratics, a skill that you should have learned in Algebra 1, and we will learn how to factor a sum and difference of cubes. You will need this green sheet of paper from your math folder that you were given at the beginning of the year. You will also need a sheet of paper to do these examples with me. Here's our first example. We are going to factor x squared minus 3x minus 40. So if you'll write this example on your sheet of paper, and if you'll look at your green sheet of paper with me as I factor this problem, I want you to get into the habit of looking at step 1 first. Step 1, check for a greatest common factor. Remove if you have one. Now what does that mean? X squared minus 3x minus 40. Do these three terms have a common factor? Here's one way that you could do this. My coefficient here is 1, so 1 times 1. I've got x squared. I've got 3, 1 times 3, 1 times x, and I have 40. 1 times 40, 2 times 20, 4 times 10. You don't have to write all this out. I'm just trying to show you how you can see if you have a greatest common factor. 5 times 8, and I think that's it. And what you do is you look at each of these and see what your greatest common factor is. Well, hopefully you notice that 1 is the greatest common factor, so I don't have a numerical common factor besides 1. And then when I look at this, like these two have x in common, but this one does not have an x, so there's not a greatest common factor for x squared minus 3x minus 40. Now, if finding the greatest common factor is difficult for you, you may want to write this down, and all I did was write the factors of this coefficient of 1. I wrote the factors of x squared. I wrote the only pair of factors for 3. I ignored this negative sign. So the only factors for 3, and then the only pair of factors for x, 1 times x. And then I wrote all the factors for 40. But there is not a greatest common factor, so I can skip to step 2. Is this, it says, do you have a binomial, a trinomial, or 4 or more terms? A binomial is 2 terms. A trinomial is 3 terms. 4 or more terms is what it says, 4 or more terms. Now, addition and subtraction signs separate terms. I have 2 subtraction signs, which means I have 1, 2, 3 terms. That means I have a trinomial. So this is a trinomial. Is this trinomial in one of these forms? Is it in the correct form? Now let me explain these forms. If you look at each of these forms, the middle exponent of x is half of the degree, or the largest exponent. So 1 is half of 2, 2 is half of 4, 3 is half of 6, 4 is half of 8. And then I added one where you have 2 variables. X and y is half of x squared and half of y squared. 2 divided by 2 is x to the first. 2 divided by 2 is y to the first. In this scenario, if you have a y squared and an x squared, the middle term has to have an x and a y. So this one is in that form because this exponent of 1, x to the first power, is half of 2. 2 divided by 2 is 1. So this is in the correct form. Do you have the correct form? For letter B, it says if yes, name A, B, and C. Ax squared plus bx plus c. Ax squared plus bx plus c. So that's what I'm going to do now. I'm going to name A, B, and C. A is 1, B is negative 3, and C is negative 40. So I named A, B, and C. Now I'm going to make a chart. I want factors of in the first column, and A times C. I should have made that chart a little lower. I'm going to erase there. You may need to erase also. Okay. Factors of A times C. A is 1, C is negative 40, so factors of negative 40 that will give me a sum of B, and B is negative 3. So I'm going to work on my list of factors first. Factors of negative 40. First of all, to multiply to get a negative. So if I want to multiply to get a negative, I would have a negative times a positive or a positive times a negative. Those are the only two ways to multiply to get a negative. So to multiply to get negative 40, positive 1 times negative 40, negative 1 times positive 40. 2 times negative 20, negative 2 times positive 20. This is negative 40, this is negative 40, so just keep checking back to make sure you have negative 40. 4 times negative 10, negative 4 times positive 10. 5 times negative 8, negative 5 times positive 8. So every one of these factors, this one, all of these multiply to give me negative 40. Okay, now, what I want to do, and we won't do this every single time, but please, please, please do this on this first example. Sum means to add. I want to add these two things together. That gives me negative 39. I want to add those two factors together. That gives me positive 39. Add the next pair of factors together. That gives me negative 18. Add the next pair of factors together. That gives me positive 18. And the next pair, that gives me negative 6. And the next pair, that gives me positive 6. And the next pair, 5 plus negative 8, that gives me negative 3. And negative 5 plus 8, that gives me positive 3. So what I'm looking for is I'm looking for the pair of factors in this list that gives me a sum of negative 3. Well, here's negative 39, 39, negative 18, 18, negative 6, positive 6, negative 3. That's what I want. Oh, let me highlight. This is what I want. So that's my pair of factors that works. This right here. Okay, now here's where it becomes a little complicated, but try not to let it be too complicated for you. What we're going to do is we're going to rewrite this trinomial. We're going to rewrite it and replace negative 3x with 5x and negative 8x. Let's do that right now. This term's going to stay the same. So this is going to stay x squared. This term's going to stay the same. It's going to stay negative 40, but negative 3x is going to change to 5x minus 8x. So let's do that. So positive 5x minus 8x. So I have rewritten this trinomial into 4 or more terms. 4 or more terms. So rewrite as 4 terms, 4 or more terms, and it says factor by grouping. So group with parentheses. So I'm going to group the first two together, x squared plus 5x. Be sure to put a plus sign in the middle. And then negative 8x minus 40 in my second group. I'm probably going to have to go up here to this empty space and finish this problem after I do the next part. Okay, so now what we're going to do is factor this trinomial, this binomial here. There's a greatest common factor. Numerically, they do not have a common factor. Numerically, 1 is their common factor. But this has x squared and this has x. So I have to factor out their common factor of x. When I'm doing that, I am dividing these by that common factor. So that green is just extra work there that helps us see how to get this answer that goes in the parentheses. X squared divided by x is x Positive 5x divided by x is positive 5. Factoring is undoing the distributive property. I want you to look. We're going to check this. X squared plus 5x turned into x times x plus 5. If you distribute x times x, is that x squared? Yes. X times 5, is that 5x? Yes. So this is the factored form of this. Now I'm going to go to the next thing. Negative 8x and negative 40. What's their common factor? Their common factor is negative 8. So I'm going to put negative 8 out here, minus 8. And I am going to divide both of these by negative 8. I don't say x because when I look at this one has an x, this one does not have an x. So I can't put x in my common factor. All right, so I'm dividing by negative 8. Negative 8x divided by negative 8 is positive x. Negative 40 divided by negative 8 is positive 5. At this point, I'll ask you, did it work? Okay, did what work? Did factoring by grouping work? And what I'm looking for is I'm looking for this binomial and this binomial to be the same. And they are. So I am going to write my final answer up here. When those two binomials are the same, you put down two empty binomials now, side by side, because it's just multiplication. Factoring is undoing the distributive property. Write down the binomial they have in common. They both have x plus 5. Then I want you to mentally, I don't want you to do this on your paper, I'm just going to do it. I want you to mentally erase, I thought I was erasing, hold on. I want you to mentally erase, it's still not working. Is that the eraser? Yes. Well, I'm so sorry. I'll just scribble it out. So mentally erase, so I'm erasing what we just wrote down. What's left? What's not scribbled out? X minus 8. That goes in the parentheses beside of it. So that's the answer to number 1. Bear with me. I really want to take my time and explain this, and I know it took a long time, so this video will take a while, but bear with me. You will get the hang of this. It'll take time, but you will. Number 2, 2g squared minus 3g minus 40. Looking at step 1 above, it says check for a greatest common factor, remove if you have one. If you understand what it means to have a greatest common factor, you may want to fast forward through the next couple of minutes. I want to go through again what I mean by greatest common factor. If you don't understand, I encourage you to listen carefully, write down what I write down so that you can understand what it means by greatest common factor. My numbers 2, 3, and 40, ignoring the negative signs. The number 2 only has one pair of factors, 1 times 2. The number 40 only has one pair of factors, 1 times 3. I think I said the number 40. Oops. The number 3 only has one pair of factors, 1 times 3. And the number 40, I'm not sure how many factors it has. 1 times 40 is 40. 40 divided by 2 is 20, so 2 times 20 is 40. 40 won't divide by 3. 40 divided by 4 is 10. 40 will divide by 5. 5 times 8. 40 won't divide by 6. 40 won't divide by 7 evenly. And 40 divided by 8 is 5. So 40 has 4 pairs of factors. So numerically, as I look at those factors, 1 times 2, 1 times 3, 1 times 40, 2 times 20, 4 times 10, 5 times 8, the only numeric factor they have in common is 1. So they do not have a numeric factor. Now how about a variable factor? Let's go look. I've got g squared. So how to get g squared is 1 times g squared or g times g. The second term has g, so 1 times g. The third term does not have a variable, so that tells me that they do not have a variable as a common factor. So I just looked at step 1. I do not have a greatest common factor. I'll go on to step 2. Step 2 asks me, is this a binomial, a trinomial, or 4 or more terms? terms are separated by addition and subtraction signs. Here's a subtraction sign, here's a subtraction sign. That means I have 1, 2, 3 terms. That means I have a trinomial. Next it says, do you have the correct form? When it asks that, do you have the correct form, it's asking you, is this exponent here, g to the first power? Is this exponent half of this exponent? Is 1 half of 2? Yes, it is. So that means it's in this, I think it's the first form. That's really tiny. I can't tell, but I think it's the first form. So I do have the correct form. So now that I know I have the correct form, I'll move on to B. If yes, name A, B, and C and make a chart. So let's name A, B, and C. A is 2 because it's A x squared or a g squared. B is negative 3. B is negative 3. And C is negative 40. And then it says to make your chart. So over here will be my chart. In this first column, I want factors of A times C. A times C would be negative 80. Factors of negative 80 that will give me a sum of negative 3. Sum of B, and B is negative 3. So let me talk again about factors of a negative. To get a negative product, I have to multiply negative times a positive or a positive times a negative. So I'm going to think about 1 times negative 80, negative 1 times positive 80. 2 times negative 40, negative 2 times positive 40. 3 won't go into 80. 4 times negative 20, negative 4 times positive 20. 5 times negative 16, negative 5 times positive 16. If I did 80 divided by 6, that would give me a decimal, I think. Yes. 80 divided by 7, yes. 80 divided by 8 would be 8 times 10, negative 10, or negative 8 times positive 10. And then 9 won't go, and 10 times 8. Now I will add the factors. 1 plus negative 80, negative 79. Negative 1 plus 80 is 79. 2 plus negative 40, negative 38. Negative 2 plus 40 is 38. You don't have to write all that out. 4 plus negative 20, that's negative 16. Negative 4 plus 20 is positive 16. 5 plus negative 16 is negative 11. Negative 5 plus 16 is positive 11. The next one gives me negative 2. The last one gives me 2. So do any of these add up to negative 3? No, they do not. So that means number 2 is not factorable. And that happens sometimes. You go through all those steps and it's not factorable. Moving on to the next one. Number 3, 3b squared minus 24b minus 27. Okay, let's go to step 1. And again, if you can find greatest common factor quickly, you are welcome to fast forward this so to get past the greatest common factor, but there are some people who struggle to see what that greatest common factor is, so I want to provide them the tools to be able to find that themselves. So let's look at our coefficients, 3, 24, and our constant 27. The factors of 3, 1 times 3, factors of 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Factors of 27, 1 times 27, 3 times 9, and I think that's it. Now, I want to look at those factors, and I want to find a common factor if I have one. They all do have 1, but I see 3. They all have a 3. Now, let's check for variables. Let's go back and look at our variables. V squared is 1 times V squared and V times V. V is just 1 times V. And 27 does not have a variable, so then that means that they do not all have a v in common, so v cannot be part of my greatest common factor. Only 3 is. So how do you handle that? What do you do? It says, check for greatest common factor. I'm reading up here. Check for greatest common factor. Remove if you have one. So let me show you how to remove that greatest common factor. So you're going to write down that greatest common factor of 3. And you're going to divide each of these terms by that greatest common factor. Remember, factoring is undoing the distributive property. So I am going to divide 3v squared by 3. That's just v squared. Negative 24v divided by 3, that's negative 8v. Negative 27 divided by 3, that's negative 9. Okay, so next, I removed my greatest common factor. I'm going on to step 2. Do you have a binomial, trinomial, or 4 or more terms? So as I look at my new, what I've written in red, my new problem, this one here, I'm looking inside here. This 3 I'm done with. I'm going to draw an arrow in just a minute down to my answer because I'm finished with that. I don't have to think about that 3 again. I'm looking inside here. So as I look inside here, I have 2 subtraction signs. That means I have 1, 2, 3 terms, which means I have a trinomial. Is this trinomial in the correct form? Is the middle exponent half of the degree or the largest exponent? Yes, it is. So then next it says name A, B, and C. So I'm going to do that. A is 1. B is negative 8. C is negative 9. And like I said, I think I'll draw it up here. I'm going to draw up here. I'm going to put 3, and I'm going to put 2 empty binomials. And here's where my final answer is going to go. So I'm sure I'll run out of space down there at the bottom of my screen. Okay, so then it says make a chart. So I'm going to come over here and make my chart. I want factors of A times C. A is 1, C is negative 9, so 1 times negative 9 is negative 9. And I want to try to find a sum of negative 8. Sum of B. And B is negative 8. So again, I don't know why I just have negative products. Hopefully one of these will be a positive. Again, I want factors of a negative. So the way to get a negative when you multiply is a negative times a positive or a positive times a negative. Factors of negative 9. 1 times negative 9, negative 1 times positive 9, 3 times negative 3, negative 3 times positive 3, which those two are the same thing. Okay, now add these. 1 plus negative 9, that's negative 8, and that's what I want. So I'm not going to go any further. That's the one I want. I can stop when I find the one that I want. And I do expect, let me reiterate here, I do expect to see all this work. Now, the work I don't expect to see, if you know how to find your greatest common factor, you do not have to do this up here. If you don't know how, then please do this up here. But if you know how to find your greatest common factor, if that's easy for you, if multiplication and division is easy for you, you do not have to write this up here. But everything you see down here, circling your answer, your table, I expect to see all that work on your paper when you do these problems. Okay, now I'm going to continue with my directions. It says rewrite as 4 terms, like 4 terms, and factor by grouping. So we're going to rewrite as 4 terms. The first term, remember, v squared stays the same. Negative 9 stays the same. What we're doing is we're replacing negative 8v with these two, with positive 1v and negative 9v. So I'm replacing negative 8v with positive 1v and negative 9v. So let's do that. I'm actually going to swap those around. I'm going to think smart. I'm going to put negative 9v and positive 1v. Now notice I didn't write the 1 because we're in Algebra 2. We do not need to write 1v. We understand that stands for 1v. And now I'm going to factor by grouping. You group the first two together, v squared minus 9v. Put a plus sign, group the last two together, v minus 9. Looking at my first group, what do these have in common? Numerically, this is 1, and this is 9. So the only thing they have in common is 1. Variably, they both have v. So v is my greatest common factor. I'm going to divide by v. V squared divided by v is v. Negative 9v divided by v is negative 9. Bring down my plus sign. What do these two have in common? What's the greatest common factor here? Well, most students would say nothing. So when they have nothing in common, then you would put 1 plus 1, and I know I said don't write 1, but in this case I need you to write it, plus 1, and then divide both of those by 1. You still have v minus 9. Now, did it work? And I'll continue that tomorrow. When you ask the question, did it work, you are looking at what's in the parentheses. You're looking at v minus 9, v minus 9. If those are the same, then the answer is yes, it worked, and I'm ready to write my final answer. And my final answer is up here. I am going to write down what I have highlighted, v minus 9, in the first pair of parentheses. It does not matter, you could put it in the second pair. And then I'm going to pretend like this isn't here, and I'm going to write down v plus 1, what's left when you pretend like that's not there. So the final answer is 3 times the quantity v minus 9 times the quantity v plus 1. That is factoring 3v squared minus 24v minus 27, undoing the distributive property. On to the next problem. 15w squared minus 25w plus 10. So the first thing that you're going to do is check for greatest common factor. I will quickly do what I was doing on those other slides. I'm going to write out these factors. 1 times 15, 3 times 5, 1 times w squared, w times w. 25w is 1 times 25, 5 times 5, and 1 times w, and then 10 is 1 times 10, 2 times 5. So do they have a common factor? They all three have 1, and they also all three have 5. So 5 is my numeric common factor, and then when I look at my variables, this has w squared, this one doesn't. This has a w, this one does, but this one does not. So w is not a common factor of all three terms. Now we are ready to factor. First we'll take out the greatest common factor of 5. So I'll write down 5 and I'll put an empty trinomial. And I'm going to divide each of these by 5 and put that answer in the empty trinomial. 15w squared divided by 5 is 3w squared. Negative 25w divided by 5 is negative 5w. And 10 divided by 5 is positive 2. And I made my trinomial a little big, and I don't think I can erase for some reason. I think I had that trouble last week. Oh, that one erased it. Okay. Okay, and so then I'll, oops. Now, I am going to bring this 5 up here. If I had a long piece of paper, I'd put it at the bottom, but this is where my answer is going to go. Now on to step 2. Is this, and I've already answered this question, is this a binomial, trinomial, or 4 or more terms? It has a minus sign and a plus sign that separates 3 terms, so it's a trinomial. So I have a trinomial. Is it in the correct form? Yes, I have a squared into the first power, a squared into the first power. And so now I'm going to name A, B, and C. So A is 3, B is negative 5, C is 2. Now I'm going to make my chart like it says there. I want factors of A times C. A times 3 times 2, which is 6. Factors of 6. So again, I got to think about it. I want factors of positive 6. How can I multiply and get a positive? A positive times a positive, or a negative times a negative. One of those two. So I want positive 1 times positive 6, negative 1 times negative 6, positive 2 times positive 3, negative 1 times, oops, negative 2 times negative 3. If I were to add, which that's what we're going to do next, a sum of b, and b is negative 5. So if I were to add a positive and a positive, that gives me a positive. If I were to add a positive and a positive, that gives me a positive. So only this one and this one are possibilities. But if I add these two together, I get negative 7, negative 2 plus negative 3 is negative 5. So this is the one that works. Okay, so I am going to replace negative 5w with negative 2, times negative 3w. So I'm going to do that now. I am going to keep the first one the same, keep 3w squared. Negative 5w is replaced with negative 2w and negative 3w, and I'm going to keep positive 2. Next, I am going to group the first two together, 3w squared minus 2w. I'm going to put a plus sign, plus, and group negative 3w plus 2, sorry. I am going to take out the greatest common factor from the first group. When I look at these two, 3 and 2 do not have a common factor, but w squared and w have a common factor of w, so I'm going to factor out w, divide both of these by w, 3w squared divided by w is 3w, negative 2w divided by w is negative 2. We're going to write down a rule for this next thing. If your term here is negative, when you're looking for a greatest common factor, then you must factor out a negative number. So I am going to write that rule. When the first term is negative, you must factor out a negative greatest common factor. So don't forget that. That's very, very important. I'm going to factor out negative. What is the greatest common factor between those two? The greatest common factor is negative, not negative 3, negative 1. So I'm going to put negative 1 here. And then negative 3w divided by negative 1 is 3w. Positive 2 divided by negative 1 is negative 2. Did it work? So remember, how are we figuring out if it worked? We look at this binomial and this binomial. Are they the same? Yes, they are. So I can write 3w minus 2 in the first binomial, and then mentally I'll get rid of this. You don't have to scribble this out on your paper. Then w minus 1 would be left for the second binomial. So that's the answer to question 4. On to question. Okay. When I look at this, the first thing I ask myself, do I have a common factor all the way across? And I'll prove to you 1 times 5, 1 times x, 1 times y, 1 times 10, 2 times 5, 1 times y, 2 times 2, 1 times 4, 1 times x, 1 times 8, 2 times 4. So as I look, they all have 1. This has 5 and this has 5, but these two don't have 5. This has x, and this one has x, and this has y, and this one has y, but not all of them have a variable. So they don't have a common factor. So step 1, I do not have a common factor. Step 2, is this a binomial, a trinomial, or 4 or more terms? Well, there's 1, 2, 3 plus signs separating 1, 2, 3, 4 terms. So I have 4 or more terms. How do I factor 4 or more terms? By grouping. I group the first two together, put a plus sign, group the last two together, and then I ask myself, what is the greatest common factor here? Well, up here you can look at my factors. 5, they both have 5 in common, and they both have y. so 5y. I'm going to divide them both by 5y. Oops, not there. I'm going to divide them both by 5y. 5y goes on the outside. 5xy divided by 5y is just x, because those cancel out and those cancel out. 10y divided by 5y, the y's cancel out. That's positive 2. Remember, when this first term is a negative, then you have to factor out a negative greatest common factor. So what do those have in common? It looks like they have negative 4. So I'm going to put minus 4, divide both of these by negative 4. That would be positive x plus 2. Okay, so my next question is, did it work? Look at this binomial. Look at what's in parentheses. Are they the same? Yes, they are. So I'm going to put 2 empty binomials. This is going to be where my answer goes. I'm going to put what they have in common here. They both have x plus 2. Then I'm going to forget about that and write down what they have that's left. So my answer is the quantity x plus 2 times the quantity 5y minus 4. On to the next. Looking at the steps, step 1, do I have a greatest common factor? Oops. 1 times 3, 1 times m cubed, m times m squared, or m times m times m. This one, 1 times 3, 1 times m. This one, 1 times 2, 1 times m n, m times n, 1 times 2, 1 times n. Those are all the factors. Do they have a common factor across the board? The only one I see they all have is 1. Hopefully you see that. This has n, this has n, this one does not. This one has m, this one has m, this one has m, this one does not. So I do not have a common factor in all 4 terms. And then I just answer my next question. Do you have a binomial, a trinomial, or 4 or more terms? Well, we have 4 terms because we have 1, 2, 3 addition or subtraction symbols. So I'm going to group the first 2 together. I'm going to put a plus sign, group the last 2 together. I am going to take out the greatest common factor of the first group, and that looks like that would be 3m. 3m cubed divided by 3m is m squared. Negative 3m divided by 3m is negative 1. And then my next group, I'm going to factor out a 2. And when I factor out a 2n, if I divide both of these by 2n, then I've got m minus 1. Now, as far as we're concerned, and I'm going to ask you and tell you, did it work? This and this are not the same. I'm not going to give you one this complicated. You are welcome to write not factorable, but this actually will factor if I keep going. It's just a little bit complicated. I will explain it, and if you want to write it down, great. But like I said, all the ones I'm going to give you, what I have in parentheses, will be the same, and this one is not. So I want to show you how it actually works. This is a binomial, this here. It's a binomial. It's a difference of squares. So I can factor that into 2 empty binomials. That's what it says up there. When you have a difference of squares, you put 2 empty binomials, one with a plus sign, one with a minus sign. And then you take the square root of m squared, that's m, and you take the square root of 1, that's 1, and I'm going to bring down the rest of this. So actually, this will factor when you look at it. Now it's different. It's different than any you're going to see, but I just want students to know that these terms have this in common. So it will factor. I'm going to make my 2 binomials. And again, this one's more complicated than any that we'll do. I will write down what they have the same, what's highlighted. M minus 1 is what's highlighted, and if you take away m minus 1, you're left with 3m times the quantity m plus 1, and then plus 2n. So technically, this answer, I'm going to distribute, I'll have 3m squared plus 3m plus 2. 3m squared plus 3m plus 2. That would be my factored form of this problem. But like I said just a second ago, it is perfectly fine for you to write not factorable, and I will continue these notes tomorrow. Looking at our steps for number 7, the first thing we want to do is check for greatest common factor. 8x to the 4th minus 32, is there a common factor? So I'll pause for a moment and write down those factors, and we will check to see if there's a common factor. As you can tell from the list of factors, there is a numeric common factor. They both have 4. Oops, I think there's a bigger one. Let me highlight in red. The biggest greatest common factor, or the biggest factor, is 8. So that's my greatest common factor. And also, please note that the first term has x's. The last term does not have x's, so that means I only have a numeric common factor of 8. So we'll write down that common factor of 8. We'll put an empty pair of parentheses, divide each term by 8. 8x to the 4th divided by 8 is x to the 4th. Negative 32 divided by 8 is negative 4. Now I'm ready to look at what is left in the parentheses. Is this a binomial, a trinomial, or 4 or more terms? We're looking at step 2. Is it a binomial, a trinomial, or 4 or more terms? This is a binomial. And then when you're looking at a binomial, you're looking for difference of squares, difference of cubes, sum of cubes, or none of those. So looking at this variable and this variable, flip your paper over. I believe the squares are here on the left. Is this in the list of squares? Yes. Is this in the list of squares? Yes. Is this subtraction? Yes. So I have a difference of squares. Looking here, I have a difference of squares. What does it say to do when you have a difference of squares? 2 empty binomials. Bring down your greatest common factor. Put 2 empty binomials. Letter B, one with an addition sign, one with a subtraction sign. Letter C, take the square root of the first term. I do expect to see this on your paper. The square root of x to the 4th is x to the 2nd. That goes in the first spot of each binomial. And then take the square root of the second term. Ignore this subtraction sign. This subtraction sign is here solely to let me know that I have a difference of squares. So I ignore that subtraction sign. I take the square root of this term and the square root of this term without the subtraction sign. And the square root of 4 is 2. Now, once you factor that difference of squares, you want to check again to see if you have a difference of squares. Well, first of all, this binomial is addition, so that's not a difference of squares. Here's a difference, because it's a subtraction, and x squared, a variable to the exponent of 2, is on your green paper, but 2 is not a perfect square. It's not in this list. So this is completed. This is the factorization of 8x to the 4th minus 32. Number 10, 4x cubed plus 4x squared minus 4x minus 4. I'm going to look at step 1. Do all of these terms have a common factor? Well, I hope without making the list that all of you can see that all of these have a 4. So 4 is the greatest common factor. Will I include a variable of x? Do all of these have an x in the term? X to the 3rd, so x times x squared, so there is an x there. X to the 2nd, x times x so there's an x there. Just x, 1 times x, so there's an x there, but is there an x here? No, so I do not have a common factor that contains a variable. I'm going to write down that common factor of 4. I'm going to divide each of these by 4 and put that answer in the parentheses. 4x cubed divided by 4 is x cubed. 4x squared divided by 4 is positive x squared. Negative 4x divided by 4 is negative x. Negative 4 divided by 4 is negative 1. Now, is this, on to step 2, is this a binomial, a trinomial, or 4 or more terms? It is 4 or more terms. So I'm going to group the first 2 and group the last 2 and put an addition sign in the middle. I'm going to put the 4 in my final answer, so I'm going to go ahead and put that down here. 2 empty binomials with a 4. And then I'm going to group the first 2 together in parentheses, put an addition sign, group the last 2 together in parentheses. My first group has x to the second in common. I'm going to divide both of these by x to the second. X to the third divided by x to the second is x to the first. X to the second divided by x to the second is positive 1. Negative x and negative 1 have a common factor of negative 1. So I am going to factor negative 1 from both of these. Negative x divided by negative 1 is positive x. Negative 1 divided by negative 1 is positive 1. Did it work? So I'm looking here and here. Are they the same? Yes, they are. This is the same as this. So I'm going to write that down. I'm going to write down x plus 1. And then I'm going to pretend like this is not here anymore because we factored out the greatest common factor. And I'm going to write down what's left, x squared minus 1. But I just noticed something as I'm factoring this. I have to check each binomial. And what made me think about it is the fact that I have a square here. This is a binomial. Binomials. I have a difference of squares. I have a subtraction, that's a difference, a perfect square, and a perfect square. I don't have the back side here, but both of these are perfect squares. So I need to erase. Whoops. I need to erase this because that is not the final answer. I'm going to put 4. I'll get my pen back. 4 here, x plus 1, and then I'm going to draw an arrow, and I'm going to bring 4 over. I'm going to bring x plus 1 over, and I need 2 empty binomials. One with an addition sign. Whoopsie, I don't know what that is. And I don't know if you all can see it. I brought something up. I don't want to get started. Done. Sorry. One with an addition sign, one with a subtraction sign. I'm going to take the square root of x squared. And that is x. It'll go in the first spot of each binomial. I'm going to take the square root of 1. That's 1. And now I know I'm finished because I do not have a perfect square variable. Like this is a perfect square, and this is subtraction, but my variable is not squared. So my final answer is 4 times the quantity x plus 1 times the quantity x plus 1 times the quantity x minus 1. Also, you could see this written this way. It does not matter to me if you write it this way, and you do not have to write this down. It just, I always say that textbook companies are saving ink by writing x plus 1 times x plus 1 is x plus 1 squared. You're welcome to write it that way, but the way I have in a box is perfectly fine also. Okay, now I think I'm switching gears. I think that's why I have this here. We have factored trinomials. We have factored 4 or more terms, and we have factored a difference of squares. All of those things, believe it or not, come from Algebra 1. None of this video so far has been Algebra 2 content until now. Now we're going to learn how to factor a sum and difference of cubes. and the cubes are here. You have to have these things in your binomials after you take out your greatest common factor. So let me go on to the next slide. Yes, so here we go. Sum of cubes, you can see I have the formula really big right here. Here kind of breaks down sum of cubes. With sum of cubes, you have an empty binomial, empty trinomial, and you use SOAP. Now, what does SOAP stand for? This sign and this sign are the same. Let me write that out right now. SOAP. Same, opposite. I don't think it says it anywhere on that sheet. Yes, I have it right beside of it. Same, opposite, always, plus. I just couldn't see that. And this is always plus. So this sign and this sign are the same. Look, this, oh, no, sorry. Rewind. This sign and this sign are the same. This sign and this sign are the same. The sign in your binomial is the opposite of the first sign in your trinomial. The sign of your binomial is the opposite of the first sign in your trinomial. And then your last sign is always plus. And then let me talk about how you get each of these things. To get the answer that goes here, you take the cube root of a cubed. This thing here, you take the cube root of it. To get the answer that goes here, you take this and do the cube root of it. Then, to get this answer, you square this. To get this answer, you square whatever this is. To get this answer, you square whatever this is. To get this answer, you square whatever this is. And then the final thing, to get this, you multiply these two. No, rewind. Forgive me on that one. You multiply these two, A and B, A times B. To get this, you multiply A and B. Okay, so let me put that into action so you can see what that looks like. Okay, looking at number 1, x cubed minus 1. Do I have a greatest common factor? No. X cubed, 1 times x cubed, x times x squared, and 1 times 1. There's not a common factor besides 1, and you don't factor out 1. Is this a binomial, a trinomial, or 4 or more terms? Well, it is a binomial. Is it a difference of squares, difference of cubes, or sum of cubes? Well, this is a cube to the third power, so it has to be a difference of cubes, or it could be, check this list over here. X to the third, so a variable to the third power is over here, and then 1 is here. So this is a difference of cubes. So following the steps there under difference of cubes, letter A says empty binomial, empty trinomial, use SOAP. The sign of your binomial is the same of the binomial. This sign and this sign are opposites, and the last sign's always plus. Now, to find what goes in your binomial, take the cube root of x cubed, that's x. Take the cube root of 1, that's 1. To find what goes here, you square this, x squared. That's what goes here, x squared. To find what goes in the last spot, to find what goes here, you square this. 1 squared is 1. Then to find what goes in the middle, to find what goes here, you multiply x times 1, and that's just x. And that's the answer to my difference of cubes, this here. So it's going to seem very overwhelming, all these different patterns, but you get used to them. You just have to study. You have to practice. Let me keep going on to. Okay, for number 2, as I look at this polynomial, 8g cubed plus 125, the first thing I'm going to do is check for a common factor. 125 is 5 times 5 times 5, or 5 times 25. And 8 is 1 times 8, 2 times 4, and they both don't have g. So this does not have a common factor. Is this a binomial, a trinomial, or 4 or more terms? Well, this is a binomial. So is this binomial a difference of squares? No, this is a cube, so it can't be difference of squares. Is it a difference of cubes? No, this is addition, so it can't be a difference either one of these. So it's a sum. Are all of these things cubes? Look in your list over here. I see 8, I see 125, and I see a variable to the third power. So I do have a sum of cubes. Okay, sum of cubes down here. Empty binomial, empty trinomial. Empty binomial, empty trinomial. Use soap. That's what letter B says. Use soap. This sign and this sign are the same. This sign and this sign are opposites. This sign and this sign are opposites. And this sign is always plus. I'm going to move this sign over just a little bit. Where's my undo button? There it is. Okay, I'll just erase. Undo wasn't working for me. Okay, so I'm going to put minus and always plus. Now, to find out what goes in this spot, I take the cube root of the first term. Cube root of 8g cubed is 2g. To find out what goes in this spot, I take the cube root of 125. Cube root of 125 is 5. Now, this next part is tricky, so just be careful. To find out what goes here, you square this. You square 2 and you square g. You have to square both of these. 2 squared is 4, g squared is g squared. So 4g squared. To find out what goes here, you square this term. 5 squared. 5 squared goes here, but don't write 5 squared, write 25. To find out what goes here, you multiply a times b. 2g times 5. 2g times 5 is 10g. And that's it. That's the answer. That's all you do. So the formula, hopefully you see from the formula, this says cube root of a cubed is a, so that's what goes in your first spot. Cube root of b cubed is b, so that's what goes in your second spot. First term of trinomial, you square. You square that a value. Last term of trinomial, you square the b value. In your middle term of your trinomial, you multiply your a and b. I probably should fill those in. You square a, you square b, and you multiply a and b. Square a, square b, multiply a and b. Okay, moving on to the next one. 5y cubed plus 1,000. So as I look at that, I know that this term is divisible by 5. So I am going to take out my common factor of 5. I'm going to divide both of these by 5. Y cubed plus 5 goes into 1,000. Let's practice dividing. 5 goes into 10 2 times. 2 times 5 is 10. 0. 5 goes into 0 0 times. 0. 5 goes into 0 0 times. So that's 200. Now, is this a binomial, a trinomial, or 4 or more terms? This is a binomial, so I'm looking in this column. Do I have difference or do I have sum? I have sum, so I'm looking here. Is this a sum of cubes? Okay, so look in your list over here. Y to the third, a variable to the third power. Yes, that is a perfect cube. 200, is it in this list? No, it's not, so I'm done. This is the answer. That's all I can do. Took out the greatest common factor. Next, 3m cubed minus 3. So I am going to take out the greatest common factor because I see they both have 3 in common. So I'm going to divide them both by 3. M cubed minus 1. Next, I'm going to see if I have a binomial, a trinomial, or 4 or more terms. This is a binomial. Do I have squares or do I have cubes? Well, this is a cube, so I have cubes. Do I have a difference or a sum? This is subtraction, so it's a difference. Are both of these perfect cubes? M to the third is 1. Yes, 1's a perfect cube. So I'm going to write down the greatest common factor, put an empty binomial, empty trinomial, and use SOAP. This sign and this sign are the same. Same. This sign and this sign are opposites. Minus, so plus. And then this sign is always a plus. Always plus. Now to find what goes here, you take the cube root of a. This is a cubed. So the cube root of a cubed is just m. So make sure that you show that work there. And then to find what goes in this spot, you do the cube root of 1, which is 1. To find what goes here, you square this. To find what goes here, you square this. To find what goes in the middle of your trinomial, you multiply these two, ignoring this sign. M times 1 is just m. And that's the answer to number 4 under sum and difference of cubes. I believe the rest of the video is practice problems. So if you want to do those practice problems and check with me to see if you're correct, I encourage you to do so, because the more you practice factoring, the better you get at it. So let's flip through and see. Extra examples not required. Answers are included, so you don't have to check with me for your answers. But if you get them incorrect, you're going to want to ask for help. So here you go. Here's some extra problems to factor. And then there's your answers to those extra problems. So that would be a great thing to do if you're struggling to learn how to factor. I would encourage you to practice, practice, practice. Have a wonderful day.